Hello, this is Mr. Koker, Module 4, Ions and Compounds. This is the module where we talk about compounds. Last module was atoms and elements. And so we're going to learn about naming and how compounds form by forming bonds, covalent and ionic. So here we're looking at a scene of the beach. And dihydrogen monoxide would be the water, silicon dioxide would be the sand, and sodium chloride, of course, is the salt that's dissolved in the water. So those would be examples of compounds and their names. Let's talk first about the Octet Rule. Why do compounds form? Well, when compounds form, typically an atom is going to gain, lose, or share electrons in order to gain an octet in its outermost or valence electron shell. Or another way of saying it is that it's going to be like a noble gas. 8 electrons in the outer energy level, or 8 valence electrons, is how noble gases maintain their stability, and so if other atoms can gain or lose electrons or share electrons to get an octet rule, they can also be stable. Gaining, losing, or sharing electrons. When electrons are lost or gained, they form ions, which is any element with a number of electrons that is different from the number of protons. Since electrons are negative and protons are positive, having a different number of them will give you a charge, and that makes an ion. Positive ions are called cations, plusicats. Notice the letter T looks like a plus sign. Negatively charged ions are called anions. How does an atom become a cation? Well, the sodium atom has 1 valence electron. It has 2 in the first energy level, 8 in the second, and 1 in the third. By losing the 1 in the third, its outermost level then becomes the second energy level, and it will have 8 in the second energy level. In other words, octet rule. Of course, losing an electron means that it now has 10 negative electrons and 11 positive protons, which will make it a +1 ion, also known as a sodium ion. How does an atom become an anion? If we think of a typical chlorine atom has 17 electrons, 2 in the first, 8 in the second, and 7 in the third. By gaining an electron, a chlorine atom can have 8 in the third level and have a noble gas octet rule arrangement. By gaining an electron, it now has 1 more negative than positive, hence it's called a chloride ion. Negative anion. So let's see if you understand this. The number of valence electrons in aluminum is, aluminum of course has 13 electrons, 2, 8, and 3. So there are 3 valence electrons in the third energy level for aluminum. The change in electrons for an octet would require, the easiest way for aluminum to get to an octet would be to lose the 3 electrons in the third energy level, leaving it 8 in the second level. If you take away 3 negatives, or in other words, if you have 10 negative charges and 13 protons, 13 positive charges, then the ionic charge for the aluminum ion will be +3. So then the symbol for the aluminum ion should be Al3+. So now let's take a look at a formation of a cation and an anion at the same time, and take a look at how both the atom losing electrons and the atom gaining electrons can both be forming octets at the same time. Magnesium has 2 valence electrons and chlorine has 7. So if two chlorine atoms were to bond with magnesium, magnesium could give one electron to each. Magnesium would become Mg plus 2, with 2 electrons in the first level and 8 in the second. And chlorine would become Cl minus 1, or chloride, with 8 electrons in the third energy level. Both, you see, form their octet rule. The magnesium is plus 2. The chloride ions are minus 1, but there are 2 of them, so an overall charge for the formula of the ionic compound, MgCl2, and an overall charge is going to be 0. We would call it magnesium chloride. Now let's talk about writing ionic formulas here. A coefficient is a number that goes in front of a molecular or ionic formula. It is meant to multiply the entire formula. This one does not have a coefficient, so that means 1 formula unit of magnesium chloride. Since magnesium does not have a subscript on it, then magnesium has only 1 ion in the formula. Chloride has a subscript of 2, so that means chloride is 2 chloride ions in the formula. So this shows magnesium and chloride with a 1:2 ratio. Let's select the correct formula now for the following ionic compounds. Sodium is plus 1, sulfide is minus 2 in order to balance the charges on the formula so that the number of electrons lost and gained would be correct. We would need 2 plus 1s for the S minus 2, so that would be the formula Na2S. Aluminum is plus 3 and chloride is minus 1, so that means aluminum loses 3 electrons and chlorine gains 1. So for the proper proportion, to get an overall neutral charge, we would need AlCl3. Magnesium is plus 2 and nitride is minus 3. The least common multiple of 2 and 3 is 6. So that would be 3 plus 2's and 2 minus 3's, or Mg3N2. Now let's talk about naming these compounds. We'll start with some simple ionic compounds from the main group elements. Main group elements are the first 2 columns and the last 6 columns. K2O, how might we name this compound, this ionic compound, which is potassium with a plus 1 charge and oxide with a minus 2 charge, looking at how many electrons they need to lose and gain to make their octet rule. Here's a little guide to naming ionic compounds. Now this would apply to all metals that form a single ion. In other words, that only have one possible charge when they form an ion. That would be true for potassium. Potassium can only make a plus 1 ion. Step 1 is to identify the cation. Cation is K plus 1, potassium. Also identify the anion. The anion is O minus 2, oxide. Step 2, name the cation by its element name. So K is called potassium. Step 3, name the anion, but change the ending of its name to "ide." So instead of oxygen, it becomes oxide. Now we put the 2 names together. Potassium oxide. K2O's name is potassium oxide. Let's practice naming these ions. Ba plus 2 would be barium. Remember, no change is made to the name of the element for the positive ions. Al plus 3 would be aluminum. K plus 1 would be potassium. Now these next 2 lines are all negative ions, so we need to change their ending to ide, nitride, oxide, fluoride, phosphide, sulfide, and chloride. Nitrogen, oxygen, fluorine, phosphorus, sulfur, and chlorine. Nitride, oxide, fluoride, phosphide, sulfide, and chloride. Now let's try writing some names. Ca, calcium. O, oxide, oxygen, oxide. K, potassium. Br, bromide. Al, aluminum. O, oxide. Notice no mention is made of the 2 and the 3. Mg, magnesium. Cl, chloride. You might wonder, how do you know what those charges are? Well, you know the charges, you know the formulas from the charges. So you might wonder how you know what the formulas are. How do you know it's Al2O3? It's Al2O3 because aluminum is +3 and oxide is -2. The transition metals actually have variable charges. They can sometimes be +1, sometimes +2, sometimes +3. They're quite unpredictable. So our guide to naming ionic compounds with variable charge metals is first to determine the charge of the cation. We determine the charge of the cation by knowing the charge of the anion and then thinking about what would make it add up to 0. CrF2, the anion is F-1. There are 2 of them, so that's a total of -2, so the Cr must be +2. Now we name the cation by its element name and a Roman numeral in parentheses after the charge. So the element name is chromium, and then a Roman numeral 2 tells me that it's Cr with a +2 charge. Step 3, we name the anion in the normal way. Fluorine becomes fluoride, and then we put the 2 names together. Chromium 2, fluoride. Let's try it on titanium and sulfur. Now the sulfide ion is -2. There are 3 of them for -6. We have 2 titanium, so they must be +3. So the charge of the cation must be +3. So the name is going to be the name of the element, titanium, Roman numeral 3. Then the anion is named in the normal way. Sulfur becomes sulfide. Put the 2 names together. Titanium 3 sulfide. Let's try these. We have Fe, iron. Iron's a transition metal, so it can have a variable charge. We have Cl -1. Remember, chlorine needs 1 more electron to get an octet, so it's -1. There are 2 -1s, so Fe must be +2. Iron 2 chloride. Iron Roman numeral 2 in parentheses chloride. FeCl3 should be iron 3 chloride. 3 -1s, Fe must be +3. Cu2O, oxide is -2. Cu then must be +1. Copper Roman numeral 1 oxide. TiS2, the S is -2, so there are 2 of those, -4, so Ti must be +4. Titanium 4 sulfide. Let's check our work. Iron 2 chloride, iron 3 chloride, copper 1 oxide, titanium 4 sulfide. IV is a Roman numeral for 4. There are also some groups of atoms that have charge. We call them polyatomics, polyatomic ions. This is the set of polyatomic ions that you will be responsible for knowing by memory. You have to memorize this group of polyatomics. You will get credit if you turn in flashcards on these polyatomic ions. They are acetate, C2H3O2-, carbonate, CO3-2, hydrogen carbonate, also known as bicarbonate, HCO3-, hydroxide OH-, nitrate NO3-, nitrite NO2-, phosphate PO4-3, ammonium NH4+1, sulfate SO4-2, and hydrogen phosphate HPO4-2, sulfite SO3-2. If you have a formula with polyatomics in it, you simply name the cation followed by the name of the polyatomic. For example, KNO3 is a combination of the K+1 ion and the NO3-1 ion known as nitrate. So K+1 is called potassium, NO3-1 is called nitrate, so we simply call it potassium nitrate. Be aware, sometimes the cation does need a Roman numeral. In this case it does not. K is not a transition metal, so it's always +1. Let's move on to covalent compounds. That's where compounds form because elements share electrons. If atoms share electrons in order to get an octet rule, then they are called covalently bonded compounds, also known as molecules. By sharing, each element is going to have a full octet. Certain elements are always found in pairs sharing electrons. We'll get to those later. They are going to be known as the lucky 7. Naming a covalent compound, here's the guide for that. We simply name the first nonmetal by its element name, and then name the second nonmetal by changing the last part to "ide." It sounds familiar to Ionic. The only difference is we also add prefixes to indicate the number of atoms. So if there are subscripts, then we need to have prefixes to indicate the number of atoms. One point of clarification needs to be mentioned here. We use prefixes on the first element and the second element, except in the case where the first element uses one atom or mono. We do never use mono on the first element. We do use mono for the second element. Otherwise, if it's di through deca, we use the prefix, even on the first element. Here we have 1 carbon and 2 oxygens. So the carbon, because it is monocarbon, we drop the mono, we just say carbon. And then there are 2 of the second oxygen here, so that's dioxide. Carbon, oxide, monocarbon dioxide, but we drop the mono on the first one, and we just call it carbon dioxide. PO5, notice once again 1 phosphorus, so we drop the mono. Phosphorus pentoxide, 1 sulfur, 6 fluorines, sulfur hexafluoride, 2 nitrogens, 1 oxygen, dinitrogen monoxide, 1 carbon, 1 oxygen, carbon monoxide. Notice we keep the mono on the second element. So that's how we would name these 4. So, simple, right? Well, it's simple until you think about just how many different rules there are. Naming simple chemical compounds means first recognizing whether it's ionic or covalent. Ionic means you have metals and nonmetals both in the formula. Covalent would be 2 nonmetals. If it's ionic, we first look at the metal. Does it form 1 positive ion? If that's the case, we use the name of the element. Or does it form more than 1 positive ion? In that case, we use a Roman numeral. In general, the transition metals are the ones with variable positive charge that need Roman numerals. On the nonmetal name, if it has only 1 single atom, then we use IDE as a suffix. If it's a polyatomic ion, then we use the memorized name for that polyatomic ion. And we always name ionics by simply naming the cation followed by the name of the anion. We don't use prefixes. With covalents, we have the first nonmetal, and we use a prefix to match the subscript. If the first nonmetal is more than one, we never put the mono on the first nonmetal. And then the second nonmetal, we always use a prefix followed by the element name with the suffix IDE. And to wrap it all up, here we have the periodic table of the elements with the 7 diatomic elements listed here. H2, N2, O2, F2, Cl2, Br2, and I2. One way to remember these are element number 7 is nitrogen. There are 7 diatomic elements, and if you look at 6 of the 7, they actually look like they draw a 7 on the periodic table. Nitrogen over to fluorine and down to iodine looks like a 7, but of course that's only 6 elements, so you need one more, which would be hydrogen. So you can call these the lucky 7 diatomic elements.